So, good afternoon, everyone. Uh, Today, we are going to start with a very important and a very informative and interesting topic, which is very current and something which is going to even judge the future of this planet. That is global climate change. In the last few classes, we have been looking at the weather and the climate. We have seen the differences between weather and climate. Then also we have seen the classification of the climate, different systems of classification. Then we have had a look at in detail the climate of Kerala and the different zones that have been designated for different areas of Kerala in ecoclimatic wise. And then we have seen some instruments which are used for measuring weather data, the standard instruments. And in the last class, we have seen how the weather data acquisition can be done using different systems, manual weather stations, automated weather stations, and data loggers. All these things we have seen. So now I am sure that you have got a very good idea about the weather and climate. And with that background, we are going to start with this particular topic, that is the global climate change. Our future lectures will be based on this one. And as you should know that this is a very important topic in the sense that many of many part of your syllabus is based on the climate change, the impact of climate change on the wildlife, both the flora and the fauna. So the topics to be covered, I am not sure whether I will be able to cover it today in 1 hour, but at least half of it is going to be covered. That is the global climate change, the phenomenon. Now, what is the phenomenon? It is actually the physics and chemistry of the global climate change and the meteorology. Now, it is very important to know this phenomenon because without knowing this phenomenon, you would be talking about anything about climate change, which could be very wrong. Unless we know the phenomenon very correctly, we won't be able to say something about climate change. Any person on the street these days say a lot about climate change. But once you know the science of climate change, you will understand that many things that they say are really non-scientific. So be very attentive to this particular class about the phenomenon, because this is going to be very important in understanding the climate change in future. Now, second, I will be talking about climate change, biodiversity, and ecosystem services, how these things are going to be affected. I am sure that we are not going to cover all these things now in today's class. Maybe in the next couple of days, we should be able to cover them. Now, let us first look at the phenomenon of climate change. Now, before trying to understand the phenomenon of climate change, let us first see two things. That is climate change and climate variability. In Malayalam, it is Vyadhyanavum Chanchalyavum. Those who do not know Malayalam, please excuse me. Make it a bit more clear, but it is not very important. Once I say these things, you will be able to understand it. Say, for example, climate variability is natural, while climate change is mostly man-made. Say, for example, this particular graph you see, the average daily maximum temperature for July in Boulder, This is in Colorado in the United States. So this is a data from 1941 to 70. And this is for the same thing, that is from 71 to 2000. So if you look at this particular graph, you can see that there is a lot of variability. Can you see that variability is there? But you can pardon? Okay, nothing is there. So there is a lot of variability happening in the daily weather pattern, and this is actually determining the temperature variability. So every year there is variability. Some years you will find that the temperature is high, and some other years you find that the temperature is not very high. And this kind of variability, this is seen for humidity, rainfall, all these weather parameters. But is it really climate change? This is the question. Now, if you try to draw a graph from here to here, you will find a slight slope, of course, there, but not very apparent here. But this is something from India only. That is from Bellini. You can see this particular graph has been produced. That is from 1984 to 2008 only. So this is about the maximum temperature. And here what you can see is that the trend in maximum temperature during August only. Pardon?
Excuse me, sir.
Sir, the slides are not moving, sir. Still the first slide is only visible.
Yeah, you are not hearing it properly. Are you not hearing it properly?
No, sir, voice is clear, but the slides, still it is the first slide.
Light.
Slide, presentation.
Slide is not clear.
Slide is not moving, sir. Still we are seeing the first slide.
Only the first slide.
Yeah.
Okay. Let me see once again. Only this particular slide you can see. Now, can you see the slides now?
For me, I cannot see it.
Let me see.
Please.
Sir, no, sir,
Let
we
me
can't
see
see
now.
now.
Once more. Can you see the slide moving now?
Yes, sir.
Yes, sir.
Yes, sir.
Now it is clear, okay?
Yeah, now it
Okay.
is clear.
Maybe only in this particular view it is possible. So I think I left out one slide. No, this I am going to talk to you about a global climate change phenomenon, which you have already understood. Now, this slide, can you get now?
Yes, sir.
Okay, now it is clear, I hope. Okay. Yeah. In this particular slide, what I want to tell you is about this temperature changes that is happening in Colorado, America. And you will see that there is a lot of variation in temperature from 1941 to 2000. But it is not very clear what kind of a variation is there. Now, this can happen anywhere, not only in the United States, anywhere. If you draw a graph of the temperature, you will find this kind of variation. But is it really climate change? Now, let's just look at this particular graph. In this particular graph, the change that you can see here is this is from Bellini, And what you can see is that the maximum temperature is drawn here. And this is in August, the maximum temperature that is coming in Velaini. And there also you find this kind of variation. But now you see, if you draw a graph, a line through the center of this one, you will find that it is not a straight line, but it is actually a slope. So from 1984 to 2008, you will find that there is an increasing trend for the temperature from this particular slope you can make out. So this kind of a particular graph where you will find a lot of changes in the temperature every year, that can be called a climate variability only. Whereas in this one, there is a clear trend of increasing temperature as years progressing. You can say that it is a climate change. Now, climate change in general is considered to be man-made because it is considered, I will come to the real reason for it, but it is something which is created man-made, which you will understand very soon. So the challenge for scientists is to determine whether any increase or decrease in precipitation, temperature, frequency of storms, sea level, etc. is due to climate variability or climate change. So two things are there. You have two terms you should know. Climate variability. Climate variability is always natural. This year the temperature may be high. Next year the temperature may not be that high. This year the rainfall is high. Next year the rainfall may not be high. Say, for example, we had floods some years. In 2018 we had very bad floods. And don't run into a big conclusion that it is all due to climate change. Now, of course, there are evidences to show that many of these things are natural calamities are happening due to climate change. But at the same time, you should not run into that it is due to climate change so suddenly. So this is very important. So what I would like you to know is that there is something called variability in weather or climate, and there is the man-made climate change also happening. Now, for that, to understand whether it is variability or whether it is due to climate change, man-made climate change, you need a long-term analysis. Now, this is a long-term analysis run in the Rubber Research Institute in Kottayam during 2006 to 2010 compared to 1960 and 64. Say, for this one, you need very old, weather data in an institution, and then you can analyze this one. So such an analysis has been done by a PhD student, and you see the difference. This is the temperature maximum and this is the temperature minimum in this graph. Now let us look at the first graph. The red one, the red line is actually indicating 2006 to 2010 mean, and the green is 1960-1964 mean. So it is actually taking only 4 years into consideration in 1960 and in 2006. So these two things are compared, the green and the red. So just look at the figure. Now this is actually the yearly variation in these 4 years. You will find that here you can see that the red line is always playing above the green line. So in 2006-2010, that the mean maximum temperature is always higher when compared to 1960-64. So this is a clear case of, you can see that it is due to climate change and not due to climate variability. Due to the change in climate variability, you can see in both these graphs. You see that it is always drawing zigzag, whereas the clear lines of the two different lines really indicate that there is a difference in temperature when we pass 50 years ahead of 1960. So that is the thing. So it is actually a 50 years comparison. Now, the minimum also you can see the variability is also there, but at the same time you can see that the variability was not, sorry, the climate change was not much during the first 2-3 years, but it changed later. So the minimum temperature is not varying much, but the maximum temperature is certainly varying throughout the year. So in winter time, this variability is not much, but in summertime and other monsoon season, the variability is much higher. So this is actually a clear case of climate change. Now, the question is whether it is induced by man or not. This is something we will have to always determine later. Okay. Now we come into another very interesting graph. It is a very internationally reputed graph, you should know. This is about the global temperature. Now look at this particular graph. Don't be afraid when you see a lot of graph. You will love to see a lot of graph in science. So this is trying to make you understand about the climate change that is happening. Now, you can see that on the x-axis, the year 1000 is there, and then 2100 is there. So every 100 years there is a marking. And on the y-axis, actually, it is the difference from the mean. So you have the mean kept as 0, and we have got the minus below and plus below above. So up to 5.5 degrees Celsius it is going, and minus 1.5 degrees Celsius it is going. So what this is actually the variability from the normal or the mean temperature. Don't think that it is the real temperature. It is the variability from the mean. I hope you understand that. Now, from the year 1000 to 1850, you will find that this variability is not very much. I mean, different centuries, it is there. Now, you may ask the question, how did you measure the temperature in the year 1000 or 1100 when the thermometer was invented only in the 19th century? Okay, this is a very justified question, but the answer is lying in your first couple of classes, which I gave you. That is, although the thermometer was invented in the 19th century, now the science is so much developed that we can find out the temperature of the air in any year, any previous years. That is, year 1000, it is possible. From where? From I-score. I have told you about the I-score determination of global temperature, and the weather data can be, that is paleoclimatology. I hope I have dealt with that particular topic in the first couple of lectures. So you can see the temperature has been taken that way, and then all these years it has been drawn, and from 1850 onwards you will find that the trend is actually towards an increasing temperature. And by 2100, the predicted temperature is about coming from 2.4 to 6.4 degrees Celsius higher than the normal temperature. So these are projections by IPCC, that is Intergovernmental Panel on Climate Change. We should know about some of these abbreviations. IPCC is Intergovernmental Panel for Climate Change. So they have actually, that is the UN organization which is actually drawing this particular graph by collecting data from different scientists. And then that is how the prediction has come now, that by the end of this century, that is by 2100, the global temperature would be somewhere between 2.4 to 6.4 degrees Celsius higher than the normal temperature. This is the normal temperature. So this is the climate change prediction. So you will, the interesting point here that you should notice is that it is only after 1850 or 1900 that this change is happening. Why this change is happening? The reason is that the main reason for this, you or many of you should be knowing, we have this industrial revolution from 1850 onwards. That is, everything changed on this earth, in the world, with the industrial revolution, That is, till 1850, it was mostly a kind of cottage industries that was prevailing everywhere in the world. Now, in the 1850s, the science and technology progressed to a great extent that they invented the steam engine. And they found that steam engine could be used to run factories, big machineries, which were being run by human effort till that time, very small machineries. So they started establishing factories, and factories started producing so much of goods. Now, in cottage industry, very few goods are produced. Whereas in a factory, you will produce goods in millions of pieces. Now, all these had to be sold. So in Europe, where this industrial revolution really happened, they started colonizing the rest of the world. And that is how the French came, the British came, the Portuguese came, the Dutch came, and all these people came to establish their colonies in rest of the countries of the world. And that is how they discovered America and they discovered Australia. So this actually changed the entire world, the Industrial Revolution. They started marketing their products. They collected the natural resources from these countries and they again processed them in Europe and started resending them to the rest of the countries. So this is actually the history of global climate change in a way. Because then what happened really? They started using a lot of fossil fuels. What are fossil fuels? Coal is one. Petroleum is another one. Diesel, petrol, all these things are fossil fuels. So by burning fossil fuels, more energy was produced. Then in the 1885 or so, in Germany, they invented the motor car. Carl Benz invented the motor car and he started driving them within Germany, and later rest of the country started buying that. And by 1930, you know that in America, the Henry Ford started producing cars in large numbers. That is the Ford cars, And then it was marketed to the rest of the world. And you know that now you have got the car industry everywhere. You have so many products coming into the market. If you want to buy anything from anywhere in the world, it is now possible. Only thing that you should have money, nothing else. Okay, and so I mean the entire market, the market culture came into the world, and this meant the use of a large quantity of fossil fuels. And it is the burning of these fossil fuels to produce energy which resulted in the evolution of a large amount of carbon dioxide by burning the fossil fuels, and which resulted in the climate change or global warming. And this is what we are going to see now. I hope you can get my points and very clear. Can Jeff tell me if that is fine?
Yes, sir.
Okay, fine. Thank you. Okay, now coming into the next slide. I was telling you about the evolution of carbon dioxide and global warming. Now, where is the evidence for it? Now, this is again another graph which is always kept side by side with the previous graph. That is CO2 concentration over the past 1000 years from ice core records. And since 1958 from the Mauna Loa, Hawaii measurement site. 1958 it is from the real measurement site, and for the previous years it is from the ice cores. The ice core technology I have explained to you in the first couple of classes. So okay, now you will find here again another graph which is very similar to the previous graph. That is, from the year 1000 it is going up. The carbon dioxide evolution is also keeping at the same, almost at a normal level, and which is at 280 ppm. That is parts per million. That is ppm, the concentration in the air. And from there here onwards, that is from 1800 onwards, again it is going up, and then almost reached 360. And this is an old graph. Now it is at around 415. It is an old graph. It is now at 415. It has risen to that level. So what is the connection between this carbon dioxide graph and the temperature graph that we have seen previously? This, you can see the shape of the graph is almost the same, isn't it? Here again, you will find the normal temperature, and it is rising after something around 1800, and carbon dioxide is showing a very similar trend. It is going up. So this is the problem. Now, scientists came to the conclusion that it is actually carbon dioxide which is creating this problem. Now, when the carbon dioxide, they found that if the carbon dioxide is increasing in the atmosphere, it means that the temperature of the atmosphere is also increasing. So they came out with new theories with regard to that. That means that 35% increase in atmospheric CO2 to 380 ppm, continuing to rise by 1 to 2 ppm a year. So every year now we are having a rise of almost 2 ppm. So it is increasing because our fossil fuel burning is increasing. Now, how this is, why do we call it is anthropogenic? The meaning, the term anthropogenic could be very new to you. Anthropogenic means something caused by human beings, something generated by the human beings. Anthropology, you have heard, that is the study of a human race. And anthropogenic actually means that the human induced or human generated. Now, these are three or four. I mean, some of the gases which have been generated by this one. That is the fossil fuels, cement and flaring. That is the gray one, forestry and other land use. Now, this needs some bit of an explanation. Fossil fuels, cement and flaring. Now, what is that? The fossil fuels, I have already told you. That is, we consume a lot of fossil fuel, especially coal, in running our thermal power stations. We get power. Of course, in Kerala, almost 40% of the power is coming from hydroelectric project. Fine. But rest of the 60% are coming from where? Thermal power stations. Ramagundam, and now the nuclear power stations from Tamil Nadu and all that. Now, so we understand why the fossil fuels are creating this problem. Then cement and flaring. What is cement and flaring? Why cement is actually causing this the evolution of carbon dioxide? I mean, how is cement manufactured? we have got the cement manufacturing in Walayar, is it not? There are quite a few factories around. Why everything is located near Walayar? We know that Walayar is relatively rich in limestones. The basic raw material for cement manufacture is limestone. So limestone is extracted from the earth, mined from the earth, and it is fused at very high temperatures. That means heated at very high temperatures. Now, what is this limestone exactly? It is nothing but calcium carbonate. Now, when limestone is actually taken, I mean, limestone is being converted into cement in cement factories. They are heating it up, and then you will find that. Can you see this thing, or has it gone? Okay, so when cement is being produced, the limestone is heated up, and limestone is calcium carbonate. You know that calcium carbonate absorbs a lot of carbon dioxide and keeps it inside. And when it is heated, this carbon dioxide is actually released into the atmosphere. So when you are manufacturing cement, you will produce a lot of carbon dioxide in the atmosphere. So this CO2 is actually contributing a lot into the atmosphere, and that is why this is actually a major, the fossil fuels and cement production. So we are building a lot of concrete buildings. We are using it on the road. Everywhere we need cement for our developments. So naturally it is producing a lot of carbon dioxide. And then forestry and other land use. How forestry is producing this carbon dioxide? Huh? We of course know that in forestry, forest really stores a lot of carbon. Don't you know? Because all the plant material, the animal material, everything is made up of carbon. But suppose this carbon is burned, what will happen? It comes in contact with the oxygen in the air, and this carbon is converted into carbon dioxide. So that is why the forest fire and such damages to the forest can really cause a lot of evolution of carbon dioxide. So that is also contributing. So these two are the major contributors of carbon dioxide into the atmosphere, which is expected to create global warming. I hope you understand that. Now, let us look at the greenhouse effect, or the real global warming phenomenon. Now, listen very carefully and look into this picture. Now, what is this greenhouse effect which has been put forward by scientists in the past 30 or 40 years? Say you have the sun, and the sun is shining and then producing a lot of radiations, and so which are called solar radiation, which passes through the clear atmosphere. Now, what are these radiations made up of? It has got a large number of different rays, and you have got short waves and long waves in it. But mostly it is the short waves that are coming and falling into the earth. Yeah? So most radiation is absorbed by the earth's surface and warms it. Now, how does it get warmed? When these actually short shortwave radiations are not warm. But when they fall on the earth, they get converted into long wave radiation or infrared rays. And that is what makes the earth heat up. So, if you, this can be demonstrated very clearly. Say you are sitting in the morning in the sun, you will find that it is a bit pleasant. It is not, the sun's rays are not very hot. But if you try to do the same thing at the noon time, you will find that everything is very hot. Is it not? So you will feel uncomfortable. Now, why is it so? The same sun in the morning and the afternoon, by noon time, is it really changing? The sun is always radiating the rays only, the same type of rays all the time. And then why are we feeling uncomfortable at noon, and in the morning we are not feeling not that uncomfortable? The reason is that as it is approaching noontime, most of the radiations of the sun are being converted into infrared rays or long wave radiation, which is actually heat. So we are feeling uncomfortable. Whereas in the morning, that conversion is not that much. And so we feel okay. So some solar radiation is reflected by the earth and the atmosphere. So it is coming here, and some are reflected and some are absorbed. Now what happens to the reflected ones? Some of the infrared radiation, these are all infrared which is getting reflected. Some of the infrared radiation passes through the atmosphere, and some are absorbed and re-emitted in all directions by greenhouse gas molecules. Now, it is very critical to understand this particular point. When this infrared rays, which from reflected from the Earth's surface, is here also emitted from the Earth's surface, they pass through the atmosphere into the space. But during that process, they come in contact with the greenhouse gas molecules. What are these greenhouse gas molecules? The topmost greenhouse gas molecule is carbon dioxide. The atmosphere contains carbon dioxide. So it is, the infrared is actually coming into contact with the carbon dioxide in the atmosphere. And then this infrared rays are re-radiated back to the earth like this. It is re-radiated with the help of the carbon dioxide and other greenhouse gases. We will see what are the other greenhouse gases later. And the effect of this is to warm the Earth's surface and the lower atmosphere. So this is not happening just once. It is happening all the time during the daytime. So from the atmosphere, the carbon dioxide and other greenhouse gases are absorbing this infrared, and they are re-radiated back, and they are forced back into the earth. So this upward and downward movement of the hot air or the infrared rays really warms up the atmosphere and later the surface of the earth also. So this is nothing but global warming. I hope you understand this one. If you have not understood, you can ask me at the end. I may be able to explain it again. So because this is very important. So this is how the real global warming happens. Now, what is the connection between global warming and climate change? There is a big connection. You know, by warming of the earth, and by warming of the earth, the movement of the air over the surface of the earth is going to change. You know that when the earth gets warmed, the air at this particular and any particular point will rise up, and cold air from other places will come and try to occupy that place. Now, along with that cold air, clouds could be also coming. And it is these clouds which will then later precipitate and come down as rainfall. Now, when the temperature is rising because of the increase in this carbon dioxide and greenhouse gases, the temperature is going up, as we have seen in the previous graphs. Because CO2 is increasing, so the temperature is also increasing. Excuse me. So now, so you will find that if the normal temperature is there, everything goes okay. But if the temperature is increasing, then this will upset the global movement of air currents or wind currents. And this will change the entire pattern of temperature as well as rainfall over the surface of the planet. And this is how global warming is connected with the climate change. So it is this greenhouse effect. This is called the greenhouse effect, which I have explained now, which is actually causing global warming. And it is global warming which will result in climate change. So this is happening on the surface of the planet, and we know that it is going to happen in future also. Okay. Now let us have a little bit of understanding of the physics of this one. Now, we know that this is the electromagnetic spectrum that is coming from the sun. What is actually coming from the sun is you will find that gamma rays are coming, X-rays are coming, ultraviolet rays are coming, then visible light are coming. Now, it is mostly in this particular range that most of the light is, at this particular wavelength, most of the rays are coming from the sun. The visible is there. That is from 350 to 700 nanometers. Now you have seen the spectrum and all that, no? The analysis of the spectrum, the VIBGYO, or the different colors and all these things. So here you can see that a lot of this visible rays are coming from the sun, and what is going out at this particular range, they are going out as infrared. This is the infrared spectrum, and this is the visible spectrum. So this is actually what is happening. So you should know that it is mostly at this particular range that is the whole result of the climate change or the greenhouse effect. So what is the greenhouse effect? Once again, the Earth's surface thus receives energy from two sources, the sun and the atmosphere. Receives energy from two sources. What is this energy? Energy as heat from two sources. The sun, which of course produces only short waves most of the time, but later get converted to infrared. So the atmosphere is also a source of energy, finally. As a result, the Earth's surface is approximately 33 degrees Celsius warmer than it would be without an atmosphere. I hope you understood this particular point. If you have not understood, I will explain it once again. The Earth's surface is 33 degrees Celsius warmer than it would be without an atmosphere. Suppose we didn't have any atmosphere. That means that we would not have had any carbon dioxide in the atmosphere. So suppose we didn't have carbon dioxide in the atmosphere, then what would have been the result? It would have been 33 degree colder than it would be with the atmosphere, without the atmosphere. So greenhouse gases are transparent to short wave but absorbs long wave radiation that the atmosphere stores energy. So the greenhouse effect, don't think that it is something induced by human being. Greenhouse effect is there because atmosphere always contains carbon dioxide. It is the increase in carbon dioxide which is creating a very extreme greenhouse effect. Greenhouse effect, it is because of the greenhouse effect that we keep warm. on this earth. Otherwise, we would have been 33 degrees Celsius colder. So this explains the average temperature of the earth is 14 degrees Celsius. That is the average temperature. If you look at the entire globe, not the Indian temperature or anything, it is the entire globe. If the greenhouse gases were not present in the atmosphere, the Earth's temperature would be minus 19 degrees. We would have experienced minus 19 degrees Celsius in our place here if the greenhouse gases were not present in the atmosphere. So, are the greenhouse gases good or not? To some extent, it is good, but increasing them is really bad. This means the greenhouse gases have been heating the earth by 33 degrees Celsius in the natural course, as I have told you in the previous slide. The greenhouse gases are actually heating up the earth by 33 degrees Celsius, and that is why we have a more pleasant temperature. Otherwise, it would have been minus 19 always on the surface of this earth. This is what the science is saying. So, what are the main constituents of the Earth's atmosphere? Now, we know that the atmosphere is made up of several gases, of which the major one is nitrogen, 78%, oxygen, 21%, argon, 1%, water vapor, 0 to 4%. And you may wonder why 0 to 4%? Because water vapor is a gas. It's a gaseous form of water, and it is always varying. That is why it is up to that much. And carbon dioxide is 0.037% in the normal course, and it is increasing. Nitrogen, oxygen, and argon hardly interact with radiation. On the other hand, water vapor and carbon dioxide both interact with infrared radiation, the type emitted by Earth and its atmosphere. A very interesting information. See, these gases which form the major gases of the atmosphere, nitrogen, oxygen, and argon, they don't react with the solar radiation or infrared radiation. Only this small percentage, that is water vapor and carbon dioxide. Now, water vapor is almost like carbon dioxide. You should know that. For example, you would have experienced like this. Suppose we have a very cloudy day and the sun is also there on a daytime there. Then you will feel very warm. Why is it so? Because the water vapor is there in the atmosphere at higher quantity, and it is showing that the same property of carbon dioxide, that is radiative forcing, which is creating infrared rays increase in the atmosphere as well as on the earth, thereby warming the earth. Now, what is a greenhouse gas? We have seen the greenhouse effect, and the gases causing the greenhouse effect are called greenhouse gases. It's defined as a gas that absorbs significantly the radiation emitted by the earth and its atmosphere. That is infrared or long wave radiation. So, a gas that absorbs significantly the radiation emitted by the earth and the atmosphere, that is the infrared rays. That is a greenhouse gas. Now, water vapor is 0.1 to 40,000, that is parts per million in volume. Carbon dioxide 370 ppm, methane 1.7 ppm, nitrous oxide 0.3, ozone 0.01, chlorofluorocarbons, that is approximately 0.0007. Probably you know what are the sources. You know what are the sources. What is the source of water vapor? Now you know what is carbon dioxide. Mostly the fossil fuels which are emitting the carbon dioxide. Methane. What is the source of methane? There are a few sources, but the major ones are agriculture is one. In agriculture, what happens is that the decaying of the material Say, when we are making compost, it is actually giving out a gas. You would have heard about a gobar gas plant. eh? That is, we use cow dung to make the cooking gas, which is methane. Now, so the methane is actually emitted by a lot of decaying compost and other vegetable masses. The nitrous oxide is actually a product from the factories. A lot of factories produce, and then oil wells in the Gulf regions and all that, they produce a lot of nitrous oxide. Then ozone is there, which is point. It's the bad ozone. The ozone up at the upper levels of the atmosphere, that is good ozone, whereas one which is in our atmosphere, it is bad ozone. Where is this ozone coming? Partly it is from burning of many fuels. Suppose we burn paper, it produces a little bit of ozone. Many other waste material, we have the habit of burning waste material, produces a lot of ozone. Then chlorofluorocarbons, you know what is the source? Mainly from refrigerators, air conditioners, which use the freons and all that. So they, from there the chlorofluorocarbons are there, very potent gases. So finally, we come to the summary of what we have studied today. That is, greenhouse gases absorb infrared radiation and prevent it from escaping to space. Okay, so I hope you have understood that. It is the greenhouse gases which will absorb infrared radiation coming from the sun and then prevent it, or the reflecting from the earth and then preventing it from escaping into space. Carbon dioxide, methane, and nitrous oxide are very good at capturing energy at wavelengths that other compounds miss. So this is what is happening in this particular process, and that is how the greenhouse effect is there. So I think I will stop my class for this hour, and maybe I will give you some time to ask a couple of questions if you have. You can, those who want to have it, you can unmute and then ask me the question. Like,
Hello, sir.
yeah, please.
Yes, sir. I just wanted to be clear that when the sun rays are entering into the Earth atmosphere, that time the greenhouse gases are working, but they are letting them in just because those are short waves. Is that right, sir?
Can you ask me that question once more? I forgot to put my speaker. Just tell me once again.
Okay, sir. So, sir, when the sun rays enter the Earth atmosphere, that time greenhouse gases are already there, but
Yeah.
they let the sun rays enter just because they are short rays, not the long waves. That is that right, sir?
Yes, yes. Okay. Yeah. The sun's rays, most of the rays that are coming from the shortwave radiation, which you have seen that. Even at the visible end, you have a lot of radiations. But when they fall on the Earth's surface, they get converted into long wave. And when the long wave radiations are trying to escape into the space, it should escape into the space, but it does not happen. It is absorbed by the greenhouse gases and then reflected back into the earth. This is exactly the greenhouse effect.
Okay, sir. Thank you, sir.
Yeah. Anything more? So this is a point that you should note, very important. That is the process of global warming and the greenhouse effect. Okay. So for the time being, since the time is over, I will wind up.
Thank you, sir.
Thank you, sir.
Thank you,
Thank
sir.
you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.